Hello and welcome, guys. This is Dramani Online Mathematics, and try to subscribe and share to your friends. Today we are going to look at homogeneous function, but we have to look at the homogeneous differential equation. But before we start with the homogeneous differential equation, let's look at homogeneous function. You realize that our last meeting or the previous meeting we talked about separable differential equation. Now the question is, if the function is not separable, how do we solve it? That's where you have to introduce that idea of homogeneous differential equation. It's one of the ways of also solving differential equation. But before we start with the homogeneous differential equation, let's start with the homogeneous function. So this is the definition of the homogeneous function. A function f at xy is said to be homogeneous of degree n in the variables x and y if for any lambda, this is a lambda, the following identity is true. Now let's look at the identity we are talking about. F of lambda x lambda y equals lambda to the power n multiplying f of x comma y, where n is a member of the integer. So let's look at something here. We are going to have this. Let's take the function this f of xy, which is here. When they give you the thing, what you are going to do is that you are going to replace the x by lambda x and replace the y by lambda y. Then you substitute that one into the equation. After that, when you factorize the lambda out and you get back the function, then you can say that that particular function is a homogeneous function. I hope you understand what I'm saying. Yes. So let's look at that. Example, determine if the function this f of x comma y equals xy plus y squared is homogeneous. And the idea is that for the thing to be homogeneous, then f of lambda x then lambda y should be equals to lambda n f of xy. Is that okay? So for it to be homogeneous, this is what's supposed to happen. So what you're going to do here is that the function given is f of xy equals xy plus y squared. So we are going to replace this xy here by lambda x lambda y, and this is going to give us, so means that wherever I see x, I'm going to replace by lambda x. Wherever I see y, I'm going to replace it by what? Lambda y. So this is going to be lambda x then lambda y plus lambda y all squared. So this is going to give us this and that. A lambda times lambda will be lambda squared multiplied by x y plus this gives us lambda squared y squared. So this is what we have. I hope you can see that. Okay. So I'm writing it up here. So you realize that now what we have is f of lambda x lambda y, which is equals to lambda square are the same, so I can factorize lambda square out, then leaving xy plus y squared. So that's what we have. Now let's see. You realize that xy plus y squared is the same as the function. So in place of this, I can write this one as f of x, y. I hope you can see that. And when something like this happens, we said that the identity what holds, and this is the identity. This must be equal to this. So this is what? Therefore, the function f of xy equals xy plus y squared is a homogeneous function with degree of n equals what? 2. So this is a homogeneous function with degree of n equals what? 2. So once you're able to factorize the lambda out and getting the original function, then you replace that one by that and you get whatever that we have here becomes the degree. So if here is just lambda, then to be n equals 1. If here is power 0, that will be n equals what? 0. I hope you understand that. Now let's look at another example. Okay, so now let's look at our next example. Given that there is a function, please remember we are dealing with homogeneous function, not homogeneous differential equation. So given that this is a function given, determine the homogeneity of this function. So by definition, if you are going to solve, let's write our definition. We are saying that f of lambda x lambda y should give us what? Lambda n of the function xy. Is that okay? So this is by the definition. So now means that if I write f of lambda x lambda y, I'm going to have, so with this is cube roots of, so wherever I see x is now lambda x, so I'm going to have lambda x cube plus lambda y cube. So f of lambda x lambda y is equals to, now let's check this. This place is going to cube root of lambda cube x cube plus lambda cube y cube. Is that okay? Good. So here, if I want to factorize, or I want to bring out, can factorize the x cube and x cube, they are the same, so I can factorize that one out. So that gives lambda x lambda y equals cube roots of lambda cube multiplied by x cube plus y cube. So f of lambda x lambda y equals, now because this is cube and this is cube root, I can take cube root of x cube and that will give us what? Just x, oh sorry, lambda. Is that okay? Leaving the cube roots of x cube plus y cube. Is that okay? Now that I'm able to bring lambda out, I think I've achieved it, because f of x lambda x then lambda y is equals to lambda f of xy. Are we seeing that? Because the original function given was this. So in place of this, I can put that function f of xy there. So it means that the function, therefore, the function f of xy equals cube root of x cube plus y cube is homogeneous with degree of n equals 1. Because this one, the lambda is just to the power what? 1. I hope you can see that. Very good. Now let's look at our last example under this. Okay, so this is our last example. So let's see how the last example looks like. So a function is defined by this, f at x of y, f at xy equals x plus 2xy. Determine the homogeneity and degree of this function. So let's see. So by definition, we are saying that f of lambda x, lambda y should give us lambda n f at xy. So by doing so, wherever I see x, I put lambda x plus lambda x again, lambda y. So f at x, lambda x, lambda y is equals to, so you realize that here I'm going to have lambda x plus lambda squared xy. Is that okay? Now with this, can we factorize the lambda out? Yes, we can do that, but you see, when we do that, still we won't get the original function that was given. I hope you can see that this is lambda, this is lambda squared. So when I bring this one out, still lambda will still be here. So once you're not getting something like that, then the degree cannot be determined. Is that okay? And it is not what? Homogeneous. So we just conclude. Therefore, or let's put this way, since the function, or since the lambda cannot be isolated from the function, then the function is not homogeneous, and therefore its degree cannot be determined. Therefore, its degree cannot what? Be determined. Is that okay? Very good. Very good. So you can just try your hands on some examples. Is that okay? Good.